next topic is model building. And we're going to be using a procedure called stepwise regression. So I'll talk about that in a minute. First, let's look at what do we mean by model building. Okay, and I'm going to go back to our Excel file and sheet 2. This is the one. And some of the numbers you may not see, but that's all right. I will provide this to you later. Okay, so now let's take an example. Here we have example with sales of salespersons in your sales team, and then we have 5 predictor variables. Sales is our target, how much sales are they bringing in. And then we have 5 features: aptitude score, age, and anxiety score, experience, and high school GPA. All right. So now we want to find the best model, best regression model that will predict sales. Now, how many different models are there for us to consider? So we can run regressions with just one predictor variable, one at a time. So go sales with X1 only, then sales with X2 only, and so on. Okay? So that would be a set of one variable model. So we have 5 of them with just one variable. And I have given the computations on the side, and these will have just one variable in the model, and these are the R-squared values. And remember, R-squared is not a good measure for comparing different models. It tells you it's a very good measure for a given model how well the fit is. But when you're comparing 2 different models of different field, different number of predictors, adjusted R-squared is a better measure. So we will look at adjusted R-squared. These are the adjusted R-squared. Now, the next level, so we now have 5 models. Now let's consider taking 2 predictor variables at a time. Okay, so out of 5, how many unique pairs are there? How many unique 2 variables are there from 5? You know how to calculate that?
5 factorial.
5 combinations 2. 5C2. So 5C2 will be 5 factorial divided by 3 factorial, 2 factorial. So that would be down here. Okay. So these are all the possible 2 variable models. And I've made the computations on the side, and these are the R-squared. Let me highlight these. These are the 2 variables, and you can already see that the first one is the best, X1 and X2, compared to all the rest. Of course, most of them are better than just one variable. Okay. So now let's consider 3 variables at the top. Now, the number of unique possibilities are 5C3, which is the same as 5C2. Okay? So here are those possibilities. X1, 2, 3, and then so on and on and on. So these are the unique possible models with 3 variables taken at the top. Okay? And the corresponding adjusted R-squared value. And then we have 4 variables taken at a time. Okay, so these are the 5 possible ways in which you can select 4 variables. And then lastly, you have all the 5 variables. Okay? Now, how many possible models there are? Okay, so there are 31 unique models available to you to select from. Okay? And of course, you can use adjusted R to make a chart. So, with just 5 variables, you have 31 possibilities. Now, if the number of predictors increases, the number of possible models to you, it actually shoots up in an exponential way. At a certain point, it becomes completely impossible for any super duper computer to go through all the possible models and figure out which one is the best. So this exhaustive search is impractical. We can't do that. So we have to find some other way of going through these variables and picking the best possible, or at least close to the best possible. Because since we are not going to be able to do exhaustive search, there is no guarantee that the model that you pick by a different method is going to be the best. But hopefully, it will be as close to the best as possible, if not the best itself. Okay? So that's what model building is. Okay?